Hello, fellow genetic gumshoes and history buffs. Welcome back to Decoding Dynasty, where we dig into the past with a metaphorical genetic shovel. Today, we're tackling a mystery that spans millennia and continents, linking some of history's most head-scratching figures. I'm talking about King Tutankhamun, the ancient Egyptian pharaoh whose looks were, shall we say, unique for the time. Then there's Niccolo Paganini, the violin virtuoso so impossibly bendy and brilliant, people swore he'd made a deal with the devil. And swinging over to American history, the towering figure of Abraham Lincoln, a man whose gangly frame was as iconic as his top hat. What in the historical genetic heck could possibly connect this ancient boy king, a demonic fiddler, and a legendary president? Did they share a secret handshake? A favorite brand of ancient cereal? Nope. The whispers from the past, often backed by modern scientific squiggles on a chart, a fat point to something far more intricate. A sneaky little genetic condition that literally stretches the limits of the human body. Now, before we get too carried away with our genetic detective hats, a quick disclaimer, dear listeners. There's no definitive genetic proof that these three historical VIPs actually had this particular condition. For now, it's mostly a very educated guess based on their historical descriptions and peculiar physiques. But hey, that's half the fun, right? Because even if it's just a strong maybe, understanding this disease helps us interpret their lives and legacies in a whole new way. So, we are diving headfirst into the world of Marfan Syndrome, a disorder of the body's connective tissue. It's a syndrome that might just explain Paganini's unholy flexibility, Lincoln's famous stature, and even some of the more unusual depictions of our pharaohs. And we'll learn all about, if they had it, what exactly that would have meant for their bodies and their lives. So buckle up, because we're about to untangle some very long limbs and even longer historical debates. Prepare to have your mind stretched as far as a Marfan limb as we decode this truly fascinating dynasty. So, what exactly is Marfan Syndrome, this genetic troublemaker that might link our seemingly disparate historical figures? Well, at its heart, quite literally, as we'll soon see, Marfan Syndrome is a genetic disorder of connective tissue. Think of connective tissue as the body's superglue, its internal scaffolding, its stretchy elastic bands, holding everything in place. Bones, muscles, blood vessels, organs, even the lenses of your eyes. Now, if you have Marfan Syndrome, this superglue isn't quite as super as it should be. The primary culprit? A tiny little mutation in a gene called FBN1, that's FBN1 for our science nerds out there, located on chromosome 15. This FBN1 gene gives instructions for making a crucial protein called fibrillin-1. Fibrillin-1 is the star player in building thread-like structures called microfibrils, which then go on to form the strong, flexible fibers of your connective tissue. Imagine building a magnificent, elastic bridge. Fibrillin-1 is like the special super strong steel cables that give the bridge its flexibility and resilience. If those cables are faulty, or there aren't enough of them because of a wonky FBN1 gene, the bridge might be built, but it's going to be a bit wobbly, prone to stretching too far, and maybe even some critical components breaking down over time. That's essentially what happens in a body with Marfan Syndrome. What's really fascinating and a bit cheeky about Marfan is that it's usually inherited in an autosomal dominant pattern. This means you only need one wonky copy of the FBN1 gene from one parent to get the syndrome. So if a parent has Marfan, there's a 50-50 chance their child will too. And in about 25% of cases, it's a brand new mutation, a genetic oopsie that just happens spontaneously. Because connective tissue is everywhere in your body, Marfan Syndrome can manifest in a whole smorgasbord of ways, with symptoms ranging from barely noticeable to life-threatening. This is super important because it explains why two people with Marfan might look and feel very different. We call this variable expression. Genetics loves to keep us on our toes. But generally, people with Marfan Syndrome tend to share some common themes. You'll often see skeletal stretchiness. Think tall and slender builds, disproportionately long arms, legs, and fingers, sometimes called arachnodactyly, which literally means spider fingers. Cool, right? They might also have really flexible joints, a curved spine, scoliosis, or a chest bone that either sticks out or caves in. Their face can also be long and narrow with a high-arched palate. Ocular oddities. Eye problems are common. The lens of the eye, which helps you focus, can actually slip out of place, called ectopia lentis, because the connective tissue holding it is weak. Extreme nearsightedness is also frequent. Cardiovascular concerns, and this is the big one, the heavy hitter, the one that can be truly life-threatening. The aorta, that massive main artery carrying blood from your heart, relies heavily on fibrillin-1 for its strength and elasticity. In Marfan, it can weaken, stretch, and bulge, an aneurysm, or even tear, a dissection. This is the primary reason why Marfan syndrome was, historically, a much more dangerous condition before modern medicine stepped in. So when we look at our historical figures, we'll be trying to spot these Marfan clues, those long limbs, the flexible joints, the specific facial features, and any historical accounts of heart or eye issues. Though, as you brilliantly pointed out, dear detective, the lack of definitive genetic evidence means these are fascinating hypotheses, not confirmed diagnoses, especially when that crucial heart problem isn't explicitly there. So there you have it, detectives. Marfan syndrome. It's a genetic blueprint gone a little stretchy, potentially leading to some very distinct features, and most critically, affecting that vital superglue throughout the body. We now know what to look for, and the delicate dance of genetics that makes every case a little different. But how do these genetic puzzle pieces fit our historical giants? Is Paganini's flexibility truly a symptom? Did Lincoln's height hide a genetic secret? And what about the pharaohs? Was Marfan just a royal red herring? Thank you for joining me on this genetic journey through history. If you found these episodes of Decoding Dynasty insightful, please like, subscribe, and share it with others who might be interested in unraveling the past through the fascinating world of genetics. Stay tuned to The Geneticist to find out what historical mystery will unravel next.